fact that we have that information.
Oh my goodness.
Congratulations on your new tripod. No, 1950s. It's not new. But thank you, Steve.
Just by way of a very quick introduction, Mr. Ashtiani is on the phone right now, and I just wanted to give a brief introduction. I know we're running a little late, so I'll make it very brief. The department filed comments, technical comments on April 27th. As part of those comments, Mr. Ashtiani, a retained outside expert from Acoustics Engineering Limited, submitted a report outlining 3 major technical issues which will be discussed today. The first one being the proposed rule's lack of a methodology for determining background ambient noise levels. Second, the use of 10-minute measurement intervals as opposed to shorter measurement intervals. And third, the proposed rule's requirement that the loudest measurement intervals be used for compliance determinations. Those 3 issues will be discussed in Mr. Ashtiani's presentation now, and I think probably the best thing to do is just to turn it over to him right now. He is in Rotterdam, and it's very late there, so I appreciate Mr. Ashtiani joining us at such a late hour. Are you there, Payam?
I'm here. Can everybody hear me?
If you could speak up a little bit, we'll try to turn you up.
All right. So just let me know at any point if it's difficult to hear me or the call quality drops.
It's good right now, so go ahead.
I know.
All right. So thanks everybody for having me, and thanks for the board and also the department for making the arrangements for me to be able to call in. It's evening here now. I'm calling through the internet, and I've sent slides, so hopefully you guys have slides to look at while I go through a very brief presentation. I understand that we're running a little bit late, so I'll try to keep it short and hopefully allow for more time for questions. Again, then just to interrupt and let me know if there's something that you can't hear.
We're all set. We have your slides. Go ahead.
Forearms.
Perfect. Okay, so going to slide number 2 is just a quick overview of the topics that I wanted to present to the board. The main topics, the main concern really is the lack of provisions for having an ambient correction to data collected as part of post-construction monitoring. There are other small aspects, but we feel that this is the main issue that can help alleviate a lot of the other portions or aspects of the proposed method. And so for that, the topics that I'd like to cover are one is the nature of ambient sound contamination, specifically transient ambient sounds and what we will call persistent ambient sounds. And then we go through the effects of different ways of filtering measurement data, potential for false exceedances, and some conclusionary remarks. Okay, so moving on to the topics, and this kind of follows the submission that we've made. So the first topic is transient noise contamination. Transient noise contamination refers to contamination of sound levels in the context of doing post-construction noise measurements from wind facilities. And the reason I've put this graph up in this slide will become evident pretty soon, but the lines that there's a light blue line and a darker line. I'm not sure if you have color or black and white copies, but one of them, the darker one, looks like step lines and more blocky, whereas the lighter blue or light blue one would be levels that kind of spike up and down. The x-axis is time, so you're going towards the right as time goes by, and the y-axis is the measured sound level at close to a resident in a rural environment, not dissimilar to what you would expect in Vermont. And the blue line shows LAEQ, so energy equivalent sound levels in 1 minute intervals. And purpose of this graph is really to show the effects of what a short-term transient event has on a 10-minute LEQ measurement. Essentially, because LEQ takes the energy average, and energy is a logarithmically scaled phenomenon. If you take the overall energy of an interval, the order of magnitude of contaminating noise is such that even though it can be a relatively short event, it can actually affect the overall level pretty substantially. And in the proposed rule, there doesn't seem to be a method to individually remove just those parts that one could assume is contaminated without having to remove an entire 10-minute interval. And so, because of the sensitivity of the LEQ, it could be that you would get a lot of false readings that have some level of contamination from noise levels, just because you're looking at things only in a 10-minute interval chunk. And so that's really the point of this graph. And then the other aspect is that if you're analyzing data that is in 10 minutes, it's relatively easy to find spikes in terms of in time and attribute them to contamination and remove them from analysis. For example, in about the middle of the graph, there's two transient events that are pretty clear to be there, even if you look at the minute intervals. Presumably will be able to be excluded even in analysis. But if you go further down, there are 2 or 3 intervals in which you have multiple contaminations. And if you're looking at data in a 1-minute interval, you can see that these are multiple contaminations. But if you're only looking at data in a 10-minute interval, it would seem as though the level is just constant and higher. So having data not be granular enough, or the ability to remove granular parts of it, can lead to either having to throw out larger amounts of data in post-instruction analysis, or leading to contaminated signal being included as part of or being assumed to be non-contaminated. If I could go to the next slide, that's slide number 4. Now this is some difference between what we call transient ambient sounds to maybe a different category that you could call persistent ambient sounds. The whole point here is there may be some sounds that are not transient in nature and may stick around for a while or be correlated to some other conditions, and we can separate those categorically from transient ones. And a couple of examples of this could be noise from insect activity that is basically constant. Now, this can easily be accounted for by looking at a frequency content and recalculating the spectrum and taking out the effect of insects. So it's definitely achievable technically. It was just not clear if the proposed method would allow for that kind of signal conditioning, I suppose. And then the other example that I could think about was if you have, especially in Vermont, a ridgeline wind farm condition in which you've got a house in a valley and turbines on top of the ridge, as well as a forested area. You could presumably have situations in which ground level wind speed could be low enough where the microphone is that it would be a valid measurement from a wind speed perspective as per the proposed methodology. However, you could have situations where the ambient noise could have a lot of vegetation noise in it that could be propagated from the wind speed at the hill or at the top of the ridge, and the amount of vegetation noise that would come from there. It's not a guarantee, but it is a possibility. And so having the avenue in the method or in the rule to be able to look at sounds like that and to be able to do that kind of analysis is probably beneficial. It's not to say that you would always need it, but if the approach that we've taken is to assume that this proposed methodology is the law and you cannot deviate from it from the way it's written. And so these are two examples where having the ability to remove contaminating events and account for the level of contamination that they would present in the signal would be highly desired. Going to the next slide. This is now slide number 5. It's titled Filtering of Measurement Data. And as I mentioned, here's a real-life example of sound measurements taken at a wind farm that is in a rural environment. And in this one, ambient levels were able to be quantified by conducting a shutdown method, not dissimilar from what RSG presented. The data points are 1 minute intervals, and the lighter one, and again, I'm not sure if you have color or if it's black and white, but there are two horizontal bands of sound levels, and the x-axis here is not time, but it's actually ground level wind speed. For us, it's always really important when you look at ambient data to look at that data in the context of the wind speed near the microphone, or at least in this case, a 10-meter height at the microphone location. And here you can see that you've got the higher band, which is the turbine plus ambient measurement scatter, and the lower band, which is just the ambient scatter. And you can see that short-term ambient events, there's plenty of them that would significantly contaminate turbine noise if they were there. And it's not to say that that they're always there, just that they're there often enough that there should be some method or ability to either remove them, or if it's not removable, to account for the difference between the on and off conditions, so that ambient noise doesn't get counted as facility noise. If we go to the next slide, now the other thing that we'd like to get into is just some examples of the variation in ambient levels. One of the exercises that we undertook in reviewing the proposed methodology and the potential effects of not having an ambient correction was to look at data sets that we have from Ontario, where the shutdown method is pretty well required, and look at just analyzing the ambient noise level. So what we took is we took 3 different sites, and we looked at just the ambient levels as compared to the proposed limit of 35 dBA. And so we can see from the first one that this is at the first site on slide 6. We've only included data where the ground level wind speed has been below 3 meters a second to be in line with what the proposed methodology here is. And this happens to be a relatively quiet site, and you can see 20 decibels most of the time. But there's some times when, even though the wind speed is very low, the ambient level is between 25 and 35, I would say. This particular site wouldn't have that much of an issue because presumably when the level does go close to 30 or 35, you'd be able to listen to it, identify it, and hopefully exclude it in the case that you would assume this is coming from the facility. Again, these measurements are with no facility running, so there's no wind turbine noise in any of this data. On the next slide, that's now slide number 7, that's a different site, and again, it's ambient noise. And in this case, you can see that it's actually a fair portion of the data would have instances of sound levels above 35 dBA. And so if the goal was to look at doing measurements to verify a facility noise of 35 dBA or less, there's a reasonable expectation, I would say, of some contribution from a measured sound level that is actually not due to the wind facility, but due to just ambient noise variation. If you can go to the next slide, that's the last example implementation of the scatter. And again, this is another site where the sound level is actually very quiet when the wind speed, the ground level wind speed, is less than 1 meter a second. So it looks like it can go as low as 16 or 17 decibels, which is not totally uncommon, and for rural environments anyway. And it does actually start to increase by the time you're at 3 meters a second. It's gone from 15 to 25. Now this could be due to local conditions of the vegetation or wind speed, wind direction orientation of other sources, but there is a relationship with wind speed. But even within that, there are times when the sound level does approach 35 decibels, and of course there are contaminating events, obviously, where the sound level goes to 50 or 55 decibels. And so the point of showing this information is not to guarantee that sound levels from ambient are always going to be always going to be low enough that you shouldn't expect any contamination. But it's just to give an idea of where what things could go wrong if the proposed methodology doesn't have the ability to remove ambient or at least account for ambient in some way. Going to slide number 9. This is a sample data set where we took the 1 minute samples that had ambient levels ranging. It might have been from one of the examples, but they would range from low levels to mid and high levels, and we actually just took the 10-minute level for one of the nights, and you can see in the x-axis it goes from 2:30 a.m. to about 5 a.m., and the sound levels are tabulated in 10-minute LAQs, and you can see that the blue line, which is just below 40 decibels, is actually the average, the arithmetic average as required by the proposed methodology. It's about 39 dBA, or just about 40, I suppose. And this is an example that if you are forced to take the top 12, then you're always forced to be looking at the levels that have the most potential for contamination. Again, this data actually doesn't include a wind farm in it, so presumably you'd want this data to easily be below 35 or much below 35. And again, this is not to say that you can't have an option of continuing to measure until the levels do fall below 35. But the difficulty here is if this was mixed with turbine noise, it would be much more complicated to be able to assess how contaminated the measured level is from ambient events. And so going to the next slide, number 10, so the very short conclusions that I wanted to make here are there's two real scenarios that I could foresee by rolling out this methodology. Is in one scenario you could have measurements that are completed and show levels below 35 dBA with the wind turbines operational, and the result would be that the compliance would be confirmed, and it would be very defendable conclusions, because even if there was ambient contamination, it would all be still below the limit. In the other scenario, it would be one where, say, the measured levels showed up that the levels are above 35 dBA, say 37. Obviously, if the levels are much higher above 35 dBA, then the possibility for contamination is lower. But if they just miss the limit, the result kind of analysis would be that non-compliance is confirmed, or at least I would presume that's the intended result. But the comment that I've included is that I could see this being challenged in that the sound levels may be argued to include some contribution from ambient levels that would push the overall level above 35. And so if the sound level limit from just the wind turbine facility is 35, and this is the methodology in which measurements are conducted, then practically I could see this running into some challenges and potentially some legal or other types of challenges of the results and of the conclusions. I think from a practical perspective, measurements period could also take very long because for the department or for anyone who is intending on conducting these measurements and getting very reliable results, you'd have to potentially spend a long time finding ideal conditions that would both satisfy the data validity requirement, so that you could say, for example, that the wind farm is operational and the wind is downwind and the background noise level is expected to be very low. It could either take very long, and I'm sure nobody is interested in having post-construction auditing take a really long time. And so I think that those are things that really should be considered, not just in the context of how measurements are completed, but also in the context of what is the level that you're ultimately trying to test compliance against. If the sound pressure level limit was something much higher, then I could see this method, although it still might take a long time for you to get the right conditions, but at least I could see the method being much more defendable because you'd look for a time with low background. All right, so that is my presentation. I figured I'd make it hopefully short enough and sweet enough that we could leave time for questions or discussion. Thank you.
Thank you. Mr. Ashtiani, this is John Cotter from the board. I was curious, one of the criticisms in the paper filing that you made had to do with the proposed rules use of the 12 loudest measurement intervals to obtain the average. And I was curious, does that concern go away if the board decides to take an approach where background sound is removed from the measurement?
I would think that it would be mitigated to a certain extent because the issue with the 12 loudest is that those are also the 12 most likely to have some contamination. So if there's an ability to quantify what the ambient would be, and if it's not, if it's quantified in pretty well the same manner, then that concern would be greatly mitigated.
Thank you.
The only addition I would put in there then is there should be some level of data quality requirement in that if the signal to noise ratio is, for example, 3 decibels or more, then you can make an assessment. But if the signal to noise ratio is much smaller than that, it becomes again more difficult to know if the levels are due to random ambient noise or if they're related to the wind turbines, or at least what component of which is in each.
Any other questions?
I have a question. Hi, this is Margaret Cheney on the board, and you've made it very clear that the 10-minute averaging is problematic in that it's more likely to be skewed by those random noise events. Are you then advocating for the 1-minute interval as a preferred substitute?
What I would advocate is that if a 10-minute interval is desired, then the ability should be there to salvage parts of the data within 10 minutes, because 10 minutes is an awful lot of time, and there could be a lot of useful noise in there. So if it has to be in 10-minute chunks, to have the ability to salvage part of it, or have a minimum part that is okay, and be able to reject the other part, or to take the total amount of minutes or time that was required for 12 10-minute intervals and make those the same amount of time requirement, but with 1-minute intervals.
And if I may build on that very quickly, the department's draft rule that is submitted November 16th, 2016 contemplated the use of 1-minute measurement intervals as opposed to 10-minute intervals.
Mr. Ashtiani, this is Kevin Pink with the board. I wanted to follow up. I think I understand the second part of your answer, which was that you were suggesting that essentially you would, instead of using, say, 12 10-minute intervals, you would use 120 1-minute intervals. The first part of your answer, I'm trying to understand, are you suggesting that you would use some sort of rolling 10-minute structure, or you would exclude an individual 1-minute unit in a 10-minute period, or I'm not sure I understand how you would accomplish that mechanically.
So my preference is for the 120 1-minute intervals easily, because it's a lot cleaner, because you're just looking at a 1-minute interval and representing it as such. The reason I suggested the other method is similar to the ANSI standard, where, for example, for an hourly LEQ, the requirement is that there should be at least 30 minutes of uncontaminated data in there so that you could represent it as if it were an hourly LEQ. You could potentially take that same approach here. But, you know, if I had to choose between the two, I would easily take the 1-minute intervals times the total amount of time required to make that the data set full enough.
So your suggestion would be if you had, 6 or something 1-minute intervals within a 10-minute, you could treat it as a valid 10-minute interval for purpose of using for calculating an average. If we're able to do it that way.
Yeah.
Any other questions? Jason?
I get
Yes.
Hi, Mr. Ashtiani. This is Sash Lewis from Dunkill Saunders. I think you and I are acquainted. What you said towards the end about the compliance methodology working better with a higher sound limit caught my ear. Is that because, in your experience, 35 dB is relatively close to ambient levels?
Yes, that's basically the reason that if the sound level limit was higher, the probability of having an ambient contamination increase the uncertainty is much less. So, for example, in Maine, where a similar method is used, the sound level limit for nighttime is actually, it's 7 dB higher than what's proposed here.
But so you also
I could see it.
Sorry, please finish.
Go ahead.
Okay, so you also expressed a concern for having an adequate signal-to-noise ratio between turbines only and ambient levels. So I guess my question is, if there's a sound limit that is too close to ordinary ambient levels, is there any compliance methodology where you would not have concerns about signal-to-noise?
Yes, if the levels are always going to be close to ambient, there are a couple of ways. The first one is you could do what Europe does, in that they measure the sound power level of the turbines, and they rely on the model to tell them what the sound level would be near the residence. And that is specifically to avoid this issue of having not enough signal-to-noise ratio to be able to be precise enough to make an assessment. The other is what they do sometimes actually in Germany, in that they'll measure much closer to the turbines or to the facility, and then do the same process by which they would use the model to calculate what it would be at someone's house. But in all those situations, they're actually moving away from measuring at the house because of the uncertainty involved in determining what the exact level is.
So is it fair to say that if what Vermont wants to do is determine compliance through direct monitoring rather than through modeling, a level of 35 dBA doesn't set us up for easy compliance determinations in the future?
Yes, I would generally agree with that. The difficulty would be finding a time that would be both representative from the turbines being downwind and generating the amount of power required, but at the same time having the ambient be quiet enough. And I have to assume that in rural Vermont is not dissimilar than rural Ontario, in that the sound level will drop below 35, and you just have to look for those times when kind of all the situations align, and you can be sure that you're not having an ambient contamination. And so I don't think it would be easy. But not only that, even if it were easy, I think if the level was determined to be non-compliant, it could set Vermont up to be challenged, and that won't be an easy thing to refute.
Thank you very much. That's all I have.
Thanks, go ahead.
Mr. Ashtiani, my name is Steve Ambrose, and I have a hard time when we determine compliance by not being present, not listening, not validating the measurement at the measurement time. Why is there such an aversion to witnessing a measurement as recommended in ANSI 12.9?
I would say that it's not an aversion as much as it is a desire to have captured the right environment. We started measuring wind turbine noise about more than a decade ago now, and that is exactly how we started measuring, in that you'd look at the forecast and you'd think that it's going to be a good day or a good night to quantify the levels, and you drive out there and you make a measurement and you try to quantify what the sound level would be. But it was, through experience, we found that the times when we would go there are what the acquisitions normally hear from the resident, is that you should have been here last night or 3 nights ago or whenever it was really, really bad. And so it turned into going from what we thought was the most ideal time to measure to what the complainant thought was most ideal time to measure, or maybe what, from a sound impact perspective, was the worst time that needed to be captured. So it became easier to leave equipment there that was sensitive enough and had the right metrology to be able to isolate those times and then verify them with audio tests. And then over time developed a methodology that actually fairly well limits the analysis to only those times when you should expect the sound level from the turbines to be maximum.
You mentioned audio tests. What do you mean by that?
What I mean is that when we do post-construction measurements, basically the standard measurements that we do now includes recording the audio on a continuous basis at a sampling rate of between 8 kilohertz and 25 kilohertz. That's what I mean.
Okay. But are you using a a mannequin, a dual microphone, so that you can get direction?
No, what we use is typically an anemometer at the microphone location. So we're not getting like a sound intensity or a sound vector, just a sound pressure level, but with an audio recording, so you could listen to it, but also with wind direction and ground level wind speed.
Right, but you know, when people go out and listen, our instruments aren't as good as a human head with 2 ears and a brain. And the fact I go out there and I hear a sound, I can say, well, that's coming from that direction. That's where the wind turbine is. Yes, I do hear that wind turbine. And my feeling is, and I know when wind is interfering with the measurement on the microphone because I monitor the microphone with a headphone. So I can hear the wind on microphone impacts where, yeah, that's a bad measurement.
I don't doubt that being there is pretty helpful. The problem that we are trying to overcome is not camping out there for 4 months and having a reasonable confidence still that the measurements that we're looking at, the overall levels that we're looking at, are predominantly from the facility and not from ambient. I agree, though, when you're on site, you can make much more observations on location of where the sound is coming from. But I would argue that for the analysis that we've done, we tend to find that when we do filter the data and we look at what's left, it's fairly clear that there's a decent amount of turbine noise in the signal that we're ended up with. So, you know, it could end up being last Tuesday at 2 a.m. But if you already have all the data there, you can quantify the overall sound level.
Because when Rob Brand and I went out and did the Bruce McPherson study, we were empowered to do it in December, and we had to wait till April till we saw the forecast was right for a front to come through the wind turbine site. And so we drove 4 hours to get to the site, did our measurements, and we lived on site for 3 days and 2 nights, got our good measurements, and left. And it was a phenomenal experience. And my feeling is I've always, when I'm trying to understand why a neighbor complains, I have to experience what the neighbor is, live as the neighbor. And this is what's bothered me now that we have these automated instruments. We've lost that ability. And we have lost the ability to do an outright compliance test. It's always uncertain.
Yeah, again, I don't disagree that being on site is definitely helpful. It's purely a result of the practicality of having to be at multiple locations at the same time. So, for example, in Ontario or in Alberta, most of the time when a post-construction commissioning measurements are required, they're required at multiple locations. And so, if there are specific times and specific wind directions where you have to, let's say, be downwind, well, it's not going to be downwind from all the residents on the same night, usually.
Yeah, well.
And so, even for one site out of many, then you'd have to basically have a person whose only job is to be at one site, because multiple sites will have problems that way. I mean, again, I'm not trying to say that the way you're proposing is inadequate, but the question is, can automated measurements be good enough?
I say no, but
I think we understand.
I'm done. I'm done.
We understand the
Right,
concept here.
the pluses and minuses.
And we wanted to let take time for the rest of
Right, and we want to leave time for Mr. Blanco.
I'm sorry. I apologize to the board.
So, and we think, we've been doing this for over 2 hours now since our lunch break, so we're gonna take a 10-minute break. And then when we come back, we'll hear from Mr. Blanco. Thanks.
Thank you, Mr. Ashtiani.
Yes, thank you.
Thank you.